The galaxy is so vast and infinite that it's likely several, if not most, space objects may elude human discovery entirely. One such object is the white hole, theorized to be the black hole's hypothetical twin. Not even light can escape the gravitational pull of black holes, which are collapsed stars that have become so dense. On the other hand, a white hole extends outwards from a space-time continuum and discharges energy in the same way as a time-reversed black hole does. What's inside these celestial wonders remains one of the biggest mysteries in physics. However, astronomers' discovery of the white hole has helped shed some light on them. Would you like to learn more about these mysterious space phenomena? Then stick to the end of this video to find out. But first, let's examine black holes in general before getting into the specifics of the white hole. A black hole is an area of space-time wherein gravity is so powerful that nothing can escape, neither particles nor electromagnetic radiation, like light. According to the general theory of relativity, a sufficiently dense mass may warp space-time to generate a black hole. Black holes are among the weirdest and most interesting things in the universe. The Milky Way may include around 100 million black holes, yet identifying these voracious space objects can be extremely challenging. Meanwhile, a supermassive black hole, Sagittarius A, was discovered in the center of the Milky Way. According to NASA, the massive body is approximately 4 million times the Sun's mass and is approximately 26,000 light-years distant from Earth. The Event Horizon Telescope team got the first picture of a black hole in 2019, and the stunning image at the heart of the M87 galaxy, 55 million light-years beyond Earth, wowed astronomers all over the world. Although black holes are difficult to be observed directly, their effect on adjacent stars may be recognized and serves as a signature. That said, a white hole has just recently been detected in space for the first time, an unexpected discovery that has NASA astronomers reconsidering what goes on within these stellar cities. The celestial monster was witnessed as it got up in the gravitational dance of death in an image acquired by the orbiting Chandra X telescope, a state that ultimately leads to a collision that emits enormous quantities of irradiation, as well as the enigmatic as yet strange phenomenon known as gravitational waves. So, what exactly are white holes? White holes are hypothetical, cosmic areas that operate inversely like black holes. It is impenetrable to everything, just as nothing can exit a black hole. White holes were once assumed to be a fabrication of general relativity, arising from the same equations as their collapsing star cousins, black holes. Nevertheless, some scientists have lately questioned whether these dual vortices of space-time are two sides of the same coin. To a spacecraft crew looking from afar, a white hole might seem identical to a black hole. It has a mass and it can spin. The bubble boundary, also known as the event horizon, which divides the entity from the rest of the cosmos, may attract a ring of dust and gas. However, if the team kept searching, they may discover something unimaginable for a black hole: a matrix. It's only in the moment when things come out that you can say, "Ah, this is a white hole," stated Carlo Rovelli, a theoretical astrophysicist at the Centre de Physique Théorique in France. A white hole, according to physicists, is a black hole's time reversal, or a video of a black hole replayed in reverse, in a similar way that a bouncing ball billiard represents a time reversal of motion. Whereas the event horizon of a black hole is a realm of no return, the event horizon of a white hole is a border of no admittance, making it the most exclusive club in space. No spacecraft can ever make it to the region's boundary. Objects within a white hole could exit and engage with the outer world, but because nothing can enter, its interior is shut off from the galaxy's past. No external event would ever impact the inside. Somehow, it's more disturbing to have a singularity in the past that can affect everything in the outside world, said James Barden, a black hole proponent and emeritus professor at the University of Washington. In 1915, Einstein's field equation slammed into the world of physics like a tsunami, and theorists are still picking through the rubble. His ideas, in addition to defining the force of gravity, sent a paradigm-shifting revelation about the nature of the universe. Time and space twist and bend with the density of planets and stars becoming more than a solid background. This realization triggered a competition to determine how much harm space might withstand from the matter that passes through it. Within 1 year, astronomer and astrophysicist Carl Schwarzschild calculated how space-time curved around a single mass object. In his response, scientists now term a singularity, which is a circular mass condensed down to an infinitely compact point surrounded by space so tightly that the region pinched off from the rest of the entire universe. It creates a no man's land where the event horizon breaks the relationship between cause and effect. The most notable singularities are black holes, where the outside universe can impact the interior of a black hole's horizon, while the inside cannot influence the outside space. Martin David Kruskal, a mathematician, expanded Schwarzschild's black hole definition to span all domains of space and time in 1960, and his resulting picture had a projection of the black hole's singularity, even though he didn't grasp its importance at the time. A suitable moniker for the theoretical twins developed as black holes became more common. It took 40 years to understand black holes, and it's only recently that people have been focusing on white holes, said Ravelli. The Event Horizon Telescope, an international partnership of 8 planet-scale ground-based radio telescopes, captured an image of the supermassive black hole at the heart of the galaxy M87 and its shadow. The M87 is depicted in polarized light. What makes it possible for white holes to exist? For a time, white holes appeared to share the same fate as wormholes, theoretically feasible space-time contortions that were presumably barred by reality. However, in recent years, some scientists have discovered white holes in a bid to protect their black siblings from an unsavory fate. Since Stephen Hawking discovered that black holes release energy in the 1970s, scientists have questioned how the phenomena may shrivel up and die. Many people wonder what happens to the inner record of everything a black hole swallows after it evaporates away. General relativity will not allow the information to escape, and quantum physics precludes it from being deleted. How does a black hole die? We don't know. How is a white hole born? Maybe a white hole is the death of a black hole. The two questions join nicely, but you have to violate the general relativity equations in the passage from one to the other, Ravelli stated. Ravelli is the creator of quantum loop gravitation, an imperfect attempt to go further than general relativity by representing space as a Lego-style construct. Using the framework's tools, he and others envision a situation in which a black hole becomes so tiny that it no more obeys the common sense principles of stars and billiard balls. Quantum randomness takes over at the particle level, and the black hole may transition into a white hole. According to Haggard, a microgram-sized white hole with the mass of a human hair will have none of the gravitational theatrics of its black hole predecessor, but instead will conceal a vast interior carrying the information of everything it had consumed in its former existence. So, quite small to draw orbiting matter, the white hole may someday be stable enough to spit out all of the information acquired by its ancestor. Conversely, the consequence of a white hole might be found everywhere. The Big Bang's burst of energy and matter appears to black hole scientists to be potentially a white hole phenomenon. The geometry is very similar in the two cases, even to the point of being mathematically identical at times, Haggard said. This image is known as the Big Bounce by cosmologists, and some researchers are looking for typical white hole patterns in the universe's first detectable light. Ravelli also wonders if powerful radio bursts are the cries of hypothetical mini black holes left behind from the Big Bang as they transform into white holes, although this theory seems more unlikely. The cosmos may not be able to wrap itself into all the forms allowed by general relativity, but Haggard believes physics ought to follow this rabbit hole to the very end. Why wouldn't you guess whether they have interesting consequences? It may be that those consequences aren't what you expected, but it would be foolhardily to ignore them, he said. So, what do you think about the mysterious white holes? Do you think they really exist? Let us know your thoughts in the comments section below. Don't forget to subscribe, and we'll see you in the next video.